Hello. In the last episode, we saw how a politely written prompt can reduce your output tokens. But what if the model ignores you? What if it still decides to give you 600 tokens when you asked for 50? That's where max tokens comes in. It's not a suggestion, it's a wall. And in production, where you're running thousands of calls a day, that wall is the difference between a predictable bill and a nasty surprise. Quick recap of where we are. We have four layers of cost optimization. We're in layer one, output control. Episode 4 was method 1, reduce output tokens by instructing the model in the prompt. That's the polite ask. Episode 5, today, is method 2, max tokens. That's the enforced limit. Think of them as two different tools for the same job. One is behavioral, one is mechanical. And in production, you want both. Here's the core problem. When you call an LLM API, the model generates tokens one by one until it decides it's done. That done decision is the model's choice, not yours. A model trained to be helpful will often be too helpful. It adds context you didn't ask for. It elaborates. It gives you 5 examples when you needed one. Every one of those extra tokens costs you money. Remember the formula from episode 3? Cost equals tokens times price per token. If your output is 600 tokens instead of 100, your output cost is 6 times higher. Across a million calls per month, that's not a rounding error. The max tokens parameter does one thing. It tells the API the maximum number of tokens the model is allowed to generate in its response. It's a hard ceiling. The model cannot go above it. Once it hits the limit, the response stops, even mid-sentence if necessary. This is different from the prompt instruction we used in episode 4. That was asking the model to be brief. Max tokens enforces it at the API level. Max tokens is a hard API cap, not a suggestion, a wall. Now, important nuance. Max tokens is a ceiling, not a floor. If the model naturally responds in 40 tokens and you set max tokens equals 100, it still stops at 40. You only pay for what was generated. And how do you know exactly how many tokens were generated? You already know the answer from episode 2, the usage block. Let's look at what the API returns. After every call, the response includes a usage block. It tells you exactly what happened. Input tokens, what you sent. Output tokens, what the model generated. And in some providers, cache read input tokens and cache creation input tokens. With max tokens in place, the output tokens field will never exceed the value you set. That means your cost calculation, which we built in episode 3, is now bounded. You know the worst case output cost before you make the call. Now, let's write the code. I'll use Anthropic's Python SDK, but the parameter exists identically across OpenAI, Gemini, DeepSeek, every provider we've covered. Let us start. Hello. In this lab, we will show what is the max token effect for Claude API call. Let's describe our code. First, we install needed libraries, python-.env. That needed for loading Claude API key from .env file. For pip install Anthropic, this is needed for calling Claude API. Secondly, we start loading API from .env file into variable name Anthropic API key. Then checking if Anthropic API key is loaded successfully or not loaded. If it is not loaded successfully, raise this error message, Anthropic Claude API not found in .env file. And if it is loaded successfully, then print Claude API key loaded successfully. And also print last 10 characters of the loaded API key. Okay, let's run this code. You can see already Claude API key loaded successfully and the last 10 characters showing here. Okay? Then we are going to show default max token code part in Anthropic Claude. And for more information about the code structures, you can check this link. Give you more information about how is the code structure for the Claude. Okay? Already we showed this in previous episode number 4. Okay, let's start the default max token. Here start with import Anthropic, then make object called client. This object, I pass the loaded API key to it. Then I make this structure, client.message.create. Define the model used and the max token here equal 1024. And this is the default value for this max token. Okay? So, I'll give it a subject default max token and the message that contain user question here. Here, user send a question. Explain what are REST APIs. Then I print the output token from usage part, then print the feedback of the model by content.content0.text. Then here I print the clock for usage.input the token and usage.output the tokens, and here to calculate the input cost and output price. For the input price, I divide the L price divide by 1 million token. And for our price divide by 1 million token. This is for use the model Claude Opus 4.5. Then here I calculate the total cost. The total cost here I multiply in the price by the input token. Some other price multiply by the other token. Okay, let's run and see the result. It takes some time to show the out. Yes, here is the output. You see, this is the output. Number of output tokens is 361 token, which is content. What is the REST API? The user questions, the model answer, REST API. This is a representational state transfer application programming interface, a set of rules and conventions that allow different software. If you want to show the full answer, okay? In good pattern, you can see here. You can go, okay? And click on the this text. You can see the output for REST, and this answer you see is very 3. Define the resources and define H3 methods. Then define stateless, what the meaning of stateless. Then define why you use REST API. So a full answer. Model give you a full answer. This answer count input 15 and output 361 with this call cost. This is now a call cost, okay? Now let's go to see what the tuning we make in max token to reduce it from default value 1024 to be 100 only, okay? With the same user questions or user query, and same calculation for the cost for input tokens and output tokens, and the sum of the total cost. Let's run and see the output. Here you see the output here is 100 tokens, so the output token is exactly, strictly follow what we defined here. We defined to be max token not exceed 100, and also the model give me the number of tokens also here, 100 token. And this answer of the REST API user query, and then give him core concept and REST principles. The input tokens here 15, and output tokens in 100, and the total cost that is calculated in this formula, okay, is equals 0.001545. And the default max token give him the cost 004560. If you go the last part to compare between the default value and the reduced max token comparison to show the report, here I make cost calculation for the uncapped cost, and the capped cost. Uncapped cost means you make default max token to 1024. Capped cost here, we make a tuning for the max token to be 100, okay? With calculation for the input tokens and the output tokens for both. Then make a difference between the uncapped, and the capped for tokens, and also for the percentage for saving. Then print the output in structured format. Let's see the output comparison summary for the input tokens, 15 versus 15. The output tokens with default max token 1024, the output tokens is 363. And when we make tuning for max token to be equal 100, so the output tokens is also equal 100. For the cost, this is the cost for 363, and this for the cost for 100 output token. The total cost for input and the plus output token. If we make just a comparison to show the saving of tokens, we save around 260 tokens with the cost of this number, with a percent in 71%. So our conclusion here, max token is a very important parameter that you can control for this value to reduce your output token cost by giving a low number, and the optimum number used to give the model good results without affecting the model result. And the next questions we will discuss is what is the best or optimum value for max token? We agree there. Now, when I reduce the max token from default value 1024 to be 100, okay, we make 71 reduced in the output token, and the cost is very reduced. But the question is coming here. What is the best optimum value for the max tokens we have to set in our code? With this answer, we will answer in next scene. There is important question there, and that is, how do you pick the right max tokens value? There's no universal answer. It depends on what your app actually needs. But here's a practical process. Step 1. Run important your typical prompts without a cap. Look at the output tokens field in the usage block. This gives you your natural distribution. Step 2. Find the 90th or 95th percentile of that distribution. That's your baseline, a length that covers most real use cases. Step 3. Add a small buffer, maybe 20-30% for edge cases. Step 4. Set that as your max tokens. This way, you're not cutting off real answers, but you are blocking runaway responses. And remember, if the model's natural response is shorter than your cap, you only pay for what was generated. The cap only kicks in when the model would otherwise overshoot. Hello again. To answer the question how to pick right or the optimum value for the max token parameter, we will show the method in this code part. First, in our code, we assume this list of output token that represents the output token count for 20 times. Okay, for 20 times, yeah. For every time we count number of tokens, so we have 20 values, okay? For the output token. And these 20 values for output tokens used for different user query for each time of 20. Okay, so for first one, we got 85 token, output token. Second one, 92. Third one, 78, till 21. 21 is 125 output token. So, okay, this is assumption, okay? And we make a list for this assumption for output token lengths. Then we make some average and the minimum and the maximum token for this range. and this to give a percentile for 90 and 95 for this list of output tokens, followed by the recommended maximum tokens that equal to P95. Go to percentile 95th percentile, multiply by 1.25. 1.25 represent 25% of safety buffer. Then print the result then here. I make cost calculation for the output for the max token, okay? And for the old cost per call and the new cost per call, and then print the result. Let run and see the code output. The output here, output token analysis, we have a number of codes of 20 time with average token 1.1, average token length 1.1, and the minimum 78 and the maximum 130. And the 90th percentile is 120, and the 95th percentile is 125, and recommend max subtoken is 156. This is coming from this percentage, 95, plus adding 25 safety buffer. This is recommended maximum token. So from here, the output is 156. So if we want to set the value of the max token in this case, I will put the max token to be 156, is the best optimum max token we can put. If we make a comparison for cost optimization for max tokens when it was thousands and recommend the maximum token 1 to 156, this is a cost of 1,000 output tokens, and this is a cost of 156 tokens. So we have a saving percentage around 84% for the saving of tokens. So in this lab, we answer the question, what is the optimum value? And the right value to set the maximum token is by trial and error. Okay, about the output token's length for 20 time here, and they make a percentile for 95th percent. Then the output I multiply with 1.425 that represent 25 safety buffer. And the output of this, I use it to set the max token parameter in the output. So, that's layer 1, output control, complete. Episode 4, prompt instructions to ask the model to be concise. Episode 5, max tokens to enforce it mechanically. Use both together. The prompt instruction reduces tokens in the normal case. Max tokens is your safety net for the unusual case. In the next episode, we move into layer 2, input control. We've been focused on the output side of the cost formula so far, but input tokens cost money too. And in many production apps, the input actually dominates the bill. The first layer 2 technique is called the sliding window, and it's about how to stop your conversation history from growing without limit.